It's probably happened to you. You're driving down a city street going 30 miles an hour, but then you drive by one of those roadside speed radars and it says you're only going 28. Now, your first thought is that that radar is just probably not calibrated, until you pass a second radar and it says the same thing. Weird, right? Now, I recently upgraded from a 2006 Buick that had a fully analog dashboard to a 2024 VW that's fully digital, and I never seemed to notice the speed discrepancy when I had the Buick. In that car, it always seemed like the speed that was on my speedometer was the same speed that the roadside radars told me. But since I got the VW, there's been a noticeable difference. It made me wonder, is the speedometer in my modern car lying to me? And if the speedometer is lying to me, what else could be wrong? Like, is my odometer showing me a higher number than reality too? And if the odometer is wrong, does that mean that the car manufacturer is ripping me off when they sell me a warranty? So I set out to find if speedometers in modern cars are lying to us, and if they are lying to us, if that means that we're getting ripped off on our warranties. Hi, my name is Nathan Denzine, and I used to be a pretty good journalist, so you can trust me. So we're going to start today's video on the road where I'm testing my car speedometer in 3 different ways to make sure that I'm not going crazy. Let's start driving and I'll explain on the way. The first test that we're going to do is one that you already saw, and that's just by driving by a roadside radar and seeing if it matches what's on my speedometer. We're going to do this on 3 different signs today because, like I said at the top, these signs are not always calibrated correctly. So what we're going to do is get 3 of them and we'll take the average and figure out how much my car is off compared to those signs. I'm going to drive by all 3 of these signs going 30 miles an hour, and we're just going to see what the difference is between my speedometer and what the radar says. All right, so we should be coming up on our first road sign radar here in a second. All right, here we go. We're going 30, and the radar says 28 or 29. Weird, right? So I guess my speed was varying there a little bit, most likely, which is why it was either flashing 28 or 29. But my speedometer said 30 that entire time, so it's definitely off by a little bit. All right, I will see you at the second stop. All right, I found another one. Let's go drive by it. Get ourselves up to 30. That one says 29. All right, there we go. That's another one. This is very consistent. We're about to come past our third radar. Oh, 31. That says 29. 27 when I drop down to 30 right there. And at least at a low speed, my speedometer is telling me a higher speed than what is real. Okay, so that is some pretty definitive evidence that my car speedometer is about 2 miles an hour faster than the real speed, but I'm not satisfied drawing conclusions from just one set of tests like that alone. So for test number 2, I'm going to find a road that's slightly faster, going about 45 miles an hour, and what I'm going to do is test the speed on my dashboard versus the speed that a GPS tracker on my phone is telling me. So let's find a road. Oh, okay, this is a 55 mile an hour road actually, so we're gonna get up to 55 and see if our speedometer agrees with us. So it turns out I can't do a screen record because I don't have enough storage on my phone, so we're gonna do this the analog way and see if it works out. My dash says 55 miles an hour. Boom, 54, there's still a difference. So we're about a mile an hour off instead of 2 miles an hour at a higher speed, but my speedometer is still telling me a higher speed than what my actual real life speed is. So we officially have pretty good evidence from both roadside radars and my phone that our car speedometer is telling us a higher speed than reality. But just to make sure, I got one more test I want to run. And for this test, we don't need any speedometers. All we need is a distance calculator and a timer. What I'm going to do is drive on a road for exactly 10 minutes going exactly 60 miles an hour. If our speedometer is accurate, then we will be at exactly 10 miles at the end of the 10 minutes. So we're going to start our timer and we're going to start our distance calculator, and at the end of 10 minutes, I'm going to show you where it stacks up. All right, I have no idea how these are going to cut together because I've tried to start this and then stopped it a few times because of traffic, but I think we finally now have gotten to a point where this is going to work. So what I've done here is I have my speedometer set at exactly 60 miles an hour as we go here. It might be a little bit different because of like hills. We might go a mile an hour slower or faster, but we're gonna leave it right here, cruise control set at 60 miles an hour, and I'll be here exactly 10 minutes later to tell you how much distance we've covered. Three, two, one. All right, chat, we have successfully driven for exactly 10 minutes. I have the trip saved. We're gonna go back and see what it looks like. Okay, so that is our trip. I don't know if it's focusing. I'll put a screenshot in the actual video. But that is our trip. So if you look at it, I stopped the timer actually about 1 second late. So we went 10 minutes and 1 second. We only went 9.9 miles, which is exactly what we'd expect if our speedometer is lying to us a little bit. You've probably also noticed it, but my max speed on here is way over 60 miles an hour, and that's just because I had to drive with the flow of traffic a couple of times. So what I did is I just timed out how long I was going over 60 and then even that out with some time going under 60 miles an hour. But the speeding up and slowing down was not that much part of the trip, and you can see that our average speed throughout the 10 minutes was 59.17 miles an hour. Basically, that means that what we found through our 3 tests is that your speedometer is lying to you by anywhere from like 1 to 2 miles an hour, depending on your speed, which does mean that I'm not crazy and that the speedometer is technically wrong. But before we all let's learn a little bit more about how cars actually tell speed and what regulations they're limited by. So we just proved that our modern cars are telling us a higher speed than reality. But like I said at the top, I never really noticed this discrepancy when I had my old Buick. And the key word there is noticed. Because when I did the smallest amount of research for this video, I learned that our cars have been lying to us for a lot longer than digital dashboards have been around. The first document I came across is a set of 1975 regulations from Europe. This document basically just set the standard for how cars could measure speed with their speedometers. For reference, in 1975, our car dashboards looked like this. Not exactly a lot of electronics. The regulations basically just said that car manufacturers had to use this formula when they were calibrating their speedometers, which looks very confusing at first, because it is. I actually had my whole family look at this, which is a calculus teacher and 2 engineers, and it took them hours to figure out how to graph this. But the gist of it is that European car manufacturers have to set their speedometers higher than your real speed. Here's how you would achieve that in a car with no computers. There's a cable that runs from your speedometer to your transmission that spins faster and faster as you speed up. And that cable is basically creating a magnetic field that pulls your speedometer along with it as you speed up too. But because of the way that cable is connected, it's actually measuring your tire rotations for your speed instead of using something like a GPS radar. For the sake of our demonstration, let's pretend that your wheels are going at about 300 rotations per minute, and that equates to about 30 miles an hour. All the manufacturer has to do is adjust all of those little mechanisms in the speedometer, and it'll tell your car that actually 250 rotations a minute is 30 miles an hour. You've now artificially inflated your speedometer because now you're telling your machine a slightly lower amount of wheel revolutions per minute reaches a target speed. This gets a lot more complicated in new cars because computers do most of the work, but the idea of wheel rotations stays the same. If we look at our graph and we do some engineering analysis, which is what my dad called it, by the way, we see the relationship between speed on the x-axis versus how much it can be off at a given speed on the y-axis. These European regulations say that at about 10 kilometers an hour, your speedometer could be off by as much as 5. And at 120 kilometers an hour, your speedometer could be off by as much as 16. But if you look at what this second graph shows, the margin of error is actually shrinking as you speed up. So the percentage difference between your real speed and the speed on your speedometer is getting lower as you get faster, which is exactly what we saw when I went out and tested it. At 30, it was about 2 miles an hour off, and at 60, it was only about 1 mile an hour off. So your car is almost definitely not off by as much as this graph shows it can be, but these are the bounds that automakers are constrained by. And while Europe might have been the first to implement this rule, the rest of the world was not very far behind. America passed its own version of the rule a few years later, and then Japan followed suit in 1992. And at this point, it's basically just a universal rule across the entire world. But why did these regulations even come about in the first place? You would think, generally speaking, that companies don't want to purposely lie to their consumers, right? Well, it's no secret that everybody likes to go fast every once in a while. In fact, speeding is probably the most common everyday crime that we're getting away with on a regular basis. In fact, I was speeding in just about all of my tests earlier, going 5 miles an hour over the speed limit. And the government knows that we're all doing this, so it already has systems in place to protect us from potentially dangerous speed. For example, the posted speed limit on any given street is usually lower than what that road is actually designed for. Because we all have a tendency to drive a little bit faster than the speed limit, the government is intentionally setting speed limits at rates lower than what's technically safe. That way, when people speed, at least within reason, they're still within the safe limitations of what that road is designed for. And that's basically the exact same reason that our speedometers are set a little bit high. It would be a really bad thing if our speedometers said we were going a lower speed than we actually were, and then we continued to speed up past the speed limit. It could create a scenario where people are unintentionally going way too fast for what's safe. According to this Australian professor, about half of all crashes could have been avoided with just 5 kilometers an hour less on the dashboard. And I should also add that your speedometer is going to get less accurate over time as your tires start to wear down. Because your speedometer is measuring the rotations of a standard stock tire, as time goes on and those wheels start to shrink a little bit, the rotation counter is going to start counting faster and faster and faster. And because it's counting more rotations per minute, it's also going to artificially inflate your speed. And I think it actually fits in this section because, unintentionally or not, I think this is actually a safety feature. As your tires degrade, they start to get more dangerous to drive on, especially at high speeds. That's because when your traction starts to wear down, your car has a lot less friction with the road, and at a high speed, you have even less friction than you are at a low speed. So when your speedometer is artificially increasing your speed because the tires are wearing down, it's unintentionally causing you to drive just a little bit slower. And like I said, I couldn't really find any information that this is technically the case, but it kind of seems like something that a safety engineer would have thought of when they were designing how these work. But then the other thing that I realized when I was researching this section is that your speedometer and your odometer are directly linked. So picture this scenario in your head. You buy a brand new car and it's got an average difference of 2% between the speed on your speedometer and your real speed. That car is also coming with a 100,000 mile warranty, but because your speedometer and your odometer are linked, that means that when you hit 100,000 miles on the odometer, you've actually only driven about 98,000 miles. And the car manufacturers know this. So are they shaving 2% off of our warranties without us even knowing it? Now, I'll say the bro science here sounds really good. A greedy corporation found a way to use government regulations in order to shave a percentage off the top for themselves. But when you think about it just a little bit, that argument also starts to fall apart. Cars and their parts are tested for durability in lab settings where engineers perform accelerated life tests on them. Basically, they take a car and then a whole bunch of its most important parts and put it through a whole bunch of extremes that it might face on the road. Then they pull a whole bunch of data points from those tests, and then they get a range of when that part is most likely to fail. But they're not necessarily looking for a specific number where it's going to fail, they're really looking at a curve. That curve is going to tell the engineers what the probability of the part failing over a certain number of miles is, and then the engineers pick a point in that curve where the risk of failure starts to increase unacceptably fast. And because we're talking about 2-ton killing machines here, these engineers are setting their safety limits much lower than what they could probably handle. If the two options are a car falling apart on the highway a little bit earlier than expected, versus just replacing a part a little bit earlier than you need to so that the car is safe, the engineers are always going to choose the latter option. So when you get a car and you see that a part has to be replaced every X number of miles, or the warranty only lasts to 100,000 miles, that's taking into account the safety regulations by the engineers, not the technical limit of how far those parts could last. It's very similar to how speedometers function, erring on the side of caution to avoid an unmitigated disaster. But compared to the 2% difference between your odometer and your real speed, the difference between how long a part could last and how long the warranty says it lasts for is huge. Everything is dependent on the car and the part that you're looking at, but the really critical pieces of your car are all tested to last 1.5 to 2 times as long as your warranty covers them for. Because the difference is so much larger than what your speedometer says it is, you're not really getting screwed when you buy your car warranty. If you had gotten a bad part or a bad car, it would have broken down much earlier than the last 2,000 miles of your warranty. Perhaps they're saving money on the margins somewhere with some cars, but for the large majority of vehicles, a bad part is going to show its face much earlier than at 98,000 miles. So no, you don't have to worry about your odometer being slightly off either. You aren't crazy, your speedometer is lying to you. And you can use any of the ways that I showed you at the top of this to test your own car to see what your average percentage error is. Either way, it's not lying to you by very much, usually just about 2%. And they set that speedometer a little bit high for safety reasons because you'd rather have somebody going a little bit slower than they think they're going rather than somebody going a little bit faster than they think they're going. And your speedometer could be off for a lot of other reasons too, like normal wear and tear on your tires. But you don't ever have to worry about it. The only time you're ever really even going to notice it is when you're going at a low speed past one of those roadside radars. And if you're worried about getting ripped off on your warranty, don't, because it's pretty much just bro science. Well, it's true your warranty isn't to the exact 100,000th mile you've driven. Don't worry, because your car parts are tested to be durable for much longer than that. If you get a bad part, the high likelihood is that it rears its ugly head much earlier than the last 2,000 miles of your journey. So yeah, don't worry about it.